In a groundbreaking turn of events, SpaceX successfully executed the 10th test flight of its enormous Super Heavy-Starship rocket, marking a pivotal moment in its journey after a series of unfortunate failures earlier this year. After a brief delay of 2 days, the launch took place on Tuesday, and despite some setbacks, the test flight was heralded as a significant achievement. Although re-entry heating caused some damage to a protective skirt surrounding the rocket's engines and partially melted a control flap, the spacecraft exhibited remarkable stability throughout its descent, ultimately culminating in a planned splashdown in the Indian Ocean. In a celebratory message posted on Platform X, SpaceX joyfully announced, "Splashdown confirmed. Congratulations to the entire SpaceX team on an exciting 10th flight test of Starship." The initial phase of the mission saw the Super Heavy's first stage performing exceptionally, efficiently propelling the Starship into the lower atmosphere before returning to the Texas Gulf Coast for a successful splashdown. During this procedure, one of the 3 engines responsible for a powered descent was intentionally shut down, simulating a failure. Yet the booster adeptly adjusted its flight path and landed precisely in the Gulf. The development team at SpaceX's facilities in Texas and California erupted in applause at various key moments throughout the 1 hour and 6-minute test flight. Their joy was palpable, especially in light of the 3 consecutive failures that had preceded this recent success. The test flight commenced when the Super Heavy's 33 methane-fueled Raptor engines ignited with tremendous force at 7:30 p.m. Eastern, launching the impressive 40-story rocket into the sky from SpaceX's Starbase, located along the Texas Gulf Coast. This long-awaited launch had been previously postponed due to issues with ground equipment and then maritime weather conditions, which obstructed an initial attempt on Monday. However, conditions were finally favorable on Tuesday, and the rocket, which is touted as the most powerful ever constructed, wowed onlookers with a spectacular ascent powered by approximately 16 million pounds of thrust, more than double that of NASA's Space Launch System moon rocket, and the renowned Saturn V. Nonetheless, concerns have been raised regarding the Super Heavy-Starship's inconsistency in performance. Many are worried that a version of the Starship, currently under development for NASA's lunar missions, may not be ready for a planned landing in 2027, especially with growing speculation about the possibility of a Chinese moon landing occurring by the decade's end. Tuesday's successful flight, while uplifting, cannot dispel the many technical challenges that still lie ahead, but it undoubtedly provided a morale boost for Elon Musk and the SpaceX team. The flight's early stages proceeded without issues, as the 230-foot Super Heavy booster effectively ejected the Starship upper stage from the lower atmosphere, separated, adjusted, and initiated a splashdown off the Texas Gulf Coast as planned. The design of the booster enables it to navigate back to its launch pad for mid-air capture by large mechanical arms, an impressive feat previously achieved in earlier tests. In this flight, however, the booster aimed for the Gulf, where flight controllers kept a watchful eye on its performance, as one engine was intentionally deactivated. Impressively, the booster managed a flawless splashdown, underlining its successful design. Meanwhile, the Starship's upper stage entered a suborbital trajectory, achieving a crucial objective that the 3 prior test flights had not met. Over the next 38 minutes, the upper stage successfully released 8 Starlink satellite simulators, testing the deployment mechanism, and briefly reignited one of its 6 Raptor engines to ensure it could restart in space. As it re-entered the atmosphere, various heat shield tiles underwent rigorous testing, revealing how the intense heat impacted the rocket structure. Although a skirt protecting the engine compartment suffered some disintegration during re-entry and one flap experienced partial melting, the Starship maintained operational control and executed commands to adjust its orientation successfully. Similar to the Super Heavy booster, the Starship is engineered to autonomously return to a launch site for mid-air capture. Nevertheless, SpaceX has yet to attempt this with the Starship, and instead, the rocket executed an accurate splashdown in the Indian Ocean. A strategically placed camera buoy captured brief footage of the rocket as it descended tail first, after suffering the expected re-entry blistering, leading to its eventual on-target landing. The rocket then exploded upon hitting the water. But this was anticipated, given the nature of the water landing. A successful test flight is essential for SpaceX as it aims to refine its systems quickly and prepare the rocket for operational missions, which include launching numerous Starlink satellites and eventually transporting settlers and equipment to Mars. These test flights are equally vital for NASA, which is depending on a modified version of the Starship to deliver astronauts to the lunar surface as early as 2027. Because the rocket is designed to be fully reusable, it will consume all its fuel en route to low Earth orbit. To transport it to the moon, SpaceX will need to conduct 10 to 20 super heavy tanker launches to refuel the lunar lander's tanks. Additionally, they must tackle the challenge of preventing natural heating of the liquid oxygen and methane fuel, which could lead to boil-off and force venting of gas into space. Historically, no orbit-class rockets have demonstrated such rapid launch sequences or successfully transfer thousands of gallons of cryogenic fuels in the challenging environment of space, where extreme temperature variations exist. One launch failure could jeopardize an entire moon mission as investigations unravel the cause, and a catastrophe in low Earth orbit could create hazardous debris, complicating future launches. Moreover, landing on the moon with a towering 16-story rocket poses its own complex challenges, primarily due to the risk of encountering uneven terrain or unstable soil that could topple the vehicle. Additionally, astronauts will need to navigate down an external platform from around 100 feet above the surface of the moon. Most experts believe that SpaceX will eventually navigate these obstacles successfully. However, the pressing question lingers. Can the company achieve this readiness by 2027 for a moon landing? Alternatively, if not, will they be able to carry astronauts to the moon prior to the Chinese establishing a presence there by the decade's end? In recent interviews conducted by CBS News with several current and former NASA managers and contractor engineers, there was a consensus that a successful moon landing in 2027 seems unfeasible given the existing human landing system architecture. Not one of them believed NASA could surpass the Chinese in a lunar landing without a significant shift in strategy. A senior engineer with experience in the Artemis program commented, "I concur with the insights you've gathered. We will not manage to send a crewed Starship to the moon by 2030 under any circumstances. This doesn't mean that we won't reach there eventually, or that the architecture can't work. But the technical advances required to achieve it in such a short time frame are monumental."